One of the things that you do when you're in manufacturing is you're always looking for a way to improve your product. So in the process of doing that, we discovered some things about our own product that we didn't know. We also discovered something about our competitors' products that they didn't know.
People have watched Apollo 13 or the space shuttle movies where you see the animation of the space shuttle coming back into the atmosphere and it gets red hot. That's aerodynamic heating. The same thing is happening with a bullet. It's just not to that order of magnitude because the velocities are lower, but the same type of phenomenon is occurring. All current polymer tip bullets, ours included, everybody else since day one when these things came out in 1984 have all been doing the same thing. The tips are getting hot and the tips are either slumping or losing shape or actually melting and losing material. And you just didn't really have any way to verify that. You don't know how long it takes these things to get hot enough for something to really start happening. You don't know what the heat capacity of these plastics are. And it was really interesting to finally have some data that goes, man, these tips have to be melting. There's no other way this bullet can be doing what it's doing without the nose of the bullet getting bigger and changing shape.
For this effect to happen, there's a couple different requirements. One is time. The bullet has to spend enough time in a certain amount of heat for that tip material to melt or deform. That's defined by the environment and the ballistic coefficient. So the higher your ballistic coefficient, the faster that bullet's going to travel for a longer period of time. It's going to be exposed to a higher heat.
The existing, easy to mold current plastics that are used, their melt points are fairly low, and I'm talking melt points from solid to liquid. And when you're talking 300-400 degrees and the bullet's seeing 800 degrees, any extended period of time of seeing 800 degrees, it deforms it.
When we made the discovery of our stuff having this issue with the BCs dropping, the tips melting and deforming, we initially thought we better make sure that none of the competitors have a solution to this. So we have tested pretty much every other polymer tipped bullet out there, and they all have the same effect.
Everybody's bullets are doing this. It's not just any one brand of bullet, it's across the board. The heat shield tips really completely make this problem go away. It's a material with 2.5 to 3 times the melting point temperature of the currently used materials. It just makes the problem go away. It doesn't exist anymore.
With the new technology, the heat shield tip technology, there is no change in the physical features of the tip. There is no change in the ballistic coefficient. There's no change in the drag. So it's true all the way throughout its entire trajectory.